Well, good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to today's DevOps.com webinar. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. We have a great webinar on tap, as always, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the event, you will have the opportunity to access it later on. Following today's webinar, we'll be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during today's presentation you have a question for any of our three panelists, please don't wait, don't hesitate, just use your GoToWebinar control panel and submit your questions. And we'll take a few minutes near the end of today's webinar and go through those. And finally, we are also doing a drawing at the end of today's webinar for three $50 Amazon gift cards. So please stick around. Hopefully you'll be one of our three lucky winners. Okay, with that, we are going to go ahead and kick off today's webinar, which is best practices for running and implementing Kubernetes. Our speakers today are Kendall Miller, who is president at Fairwinds. Hi, Kendall. Wave.
Hello.
Wave for the audience. Okay. Then we have Luke Reed, who is a site reliability engineer at Fairwinds. Hi, Luke. How are you?
Hey, great. How you doing?
Great, great. And then finally, we have Ivan Fetch, who is also a site reliability engineer at Fairwinds. Hi, Ivan. How are you?
I'm doing great. Thanks a lot.
Great, great, great. Well, Kendall, I know you are going to kick things off, so I'm going to put myself on mute, take myself off camera, and let you get right to it.
Sounds good. Thank you, Charlene. Well, yeah, good morning, good afternoon, good evening, depending on where you are in the world. This is best practices for running and implementing Kubernetes. If this is not what you came for, I guess this is what you're going to hear anyways. So thanks for coming. Let's dive in. We were already introduced briefly, but we'll say hello quickly. I'm Kendall Miller. I'm president here at Fairwinds. This is the marketing team mocking me with the most flattering image they can find of me. And Luke, would you like to introduce yourself?
Sure, yeah, I'm a site reliability engineer at Fairwinds. In this picture, I'm less bearded.
Awesome. Hi, my name is Ivan Fetch. I'm also a site reliability engineer with Fairwinds.
And we're going to give you a brief overview of who Fairwinds is, and then we'll dive into some of this. So first of all, Fairwinds is a Kubernetes enablement platform, and we use this word enablement platform because we're a combination of services and software. So enablement speaks to the services that we offer. The platform speaks to the software that's involved in our offering. The short version of it is we help people build and maintain secure, reliable, scalable Kubernetes infrastructure. So lots and lots of companies come to us and say, we want to get to market faster. We want to use Kubernetes and we don't know how to do it. How do we get started? And that's what Fairwinds exists to do. We leverage open source technologies. There's nothing proprietary about what we build, but we help companies get to Kubernetes in production quickly through a combination of those software and services. So that's who we are. We manage lots and lots of clusters at scale. Here's a few details about us. Been in business for about 5 years. We're 100% focused on Kubernetes and container infrastructure. This is relevant because all of the things we're going to talk about today, you're learning from engineers who do manage lots of clusters across lots of different clients. We have hundreds of clusters in total, thousands of deployments, a number of leading open source projects. We have a lot more than 6, but 6 that are well known. Services and software built upon best practices, and we're focused on enablement for our customers. So the average company, when they decide they want to implement Kubernetes, is going to go out and hire 3 to 5 engineers, spend 5 to 6 months kicking the tires on Kubernetes and try to get some services up and running in Kubernetes. And after 5 to 6 months, they'll have 1 or 2 services running, often poorly. Or they can come to us, we can build things and go very, very quickly. And then we have a managed service where we actually run pager, monitor the infrastructure, et cetera, make sure that everything's up and make sure that the customer succeeds long term. So we do that on all 3 of the major clouds. We also partner with Datadog, CircleCI, Rancher, a few of our customers listed here. So that's who we are. After 4 years of managing lots and lots of Kubernetes infrastructure and learning a lot of things the hard way, we're going to be talking about some of that so that hopefully you learn from some of our battle scars here without having to do it yourself. Please do ask questions throughout. There is a question box in GoToMeeting. You can drop questions in there, and at the end we will get to answering those questions. So depending on how long-winded we get, we'll have time for more or less questions. The agenda today, we're going to talk about considerations and common pitfalls when implementing Kubernetes. That'll be mostly from me, and then I'll be turning things over to the engineers, Ivan and Luke, to talk about best practices for running Kubernetes in production and security implications when adopting Kubernetes. There's lots of sub-points under this, but these are the high-level things we'll be covering today, and then we'll have time for question and answer at the end. So, considerations and common pitfalls when implementing Kubernetes. And Ivan and Luke, feel free to interrupt me and add here if you have things that you want to say. So, what are the common things that people come to Fairwinds for? So, as I mentioned, I think Kubernetes, it's pretty obvious it's a buzzword, and there's more and more companies adopting it. Everyone wants in on this promise of this new technology that's making the cloud easier, more accessible, giving an API to engineers rather than a whole bunch of complicated cloud-specific services for interacting with deployments, with their services that they're deploying as engineers individually. There was a time not that long ago where we had to build our own services, our own servers, everything from the operating system up. And today with Kubernetes, you get a simple API, and engineers can understand how to work with that. They don't have to separate ops and dev as a result of that. So there really is some amazing things about Kubernetes. Everyone wants it. The average company is afraid to implement it because they're afraid they can't do it quickly enough, they can't do it securely enough, or they can't do it reliably enough. So if it's going to take you 3 years to adopt Kubernetes, most companies are afraid of going after that. If you're going to build it, it's going to be insecure, or it's going to fall over in 6 months, that's terrifying to a CTO or a CIO. So the average company that's coming to us is saying, we want to do this, and we want to do it right the first time, and we don't want to learn all of the lessons the hard way, which makes sense. We have learned lots and lots of lessons over the 4 years of running Kubernetes, many of them the hard way. So why Kubernetes instead of serverless or ECS or Heroku or another PaaS? I like to point to a quote from Kelsey Hightower, principal engineer at Google, who said, every company wants a PaaS, they just want a PaaS that they built themselves. And Kubernetes right now is probably the closest thing we have to a framework for building infrastructure as code, for building a PaaS. It's a foundation for your own personalized PaaS. Now, PaaS is a loaded term, so that's not necessarily a direct correlation, but Kubernetes, instead of serverless or ECS or Heroku, companies use Kubernetes because there's a little bit of a promise of cloud agnosticism, although that's probably a little bit overhyped. It is definitely more cloud agnostic if you're running your workloads in Kubernetes than other places, but often people are moving to Kubernetes because they need more flexibility than a Heroku or an ECS or another PaaS offers, or they've reached some pain point in terms of cost and scale. So when you're running something at a really big scale, oftentimes you want to switch to Kubernetes, build it yourself, make sure that it's customized to meet your needs. Anything I'm missing there, Ivan, Luke, anything you'd add? Okay, well, as long as I keep being completely coherent, I'll keep talking. Will Kubernetes help implement a DevOps culture? This is something that people often ask us. Hey, we want to put the Kubernetes in because we want the DevOps. This is not an unusual thing to hear. The short of that is that tools often amplify and reflect culture. Now, these are words that I'm stealing directly from Ivan, but it's true that your culture will be amplified with the tools that you use. So yes, Kubernetes does enable a lot of things that make DevOps culture easier. As I mentioned, an engineer has an API to which they can deploy the service that they have built. They can see it running in a staging environment. They can deploy it into a production environment without having to go to ops and say, well, how big of an instance do I need? How does deployment work across here, here, and here? What needs to interact with all my other services? Kubernetes simplifies a lot of that, so it can help implement a DevOps culture. However, a tool alone won't get you there. If you're having problems in your company culture of having engineers own the services that they've deployed, see them all the way through to production, Kubernetes isn't going to make all of your problems go away. Finally, these problems are scary to a lot of companies. How does Fairwinds tackle this? So we, as I mentioned, have been in business for 5 years. We've been doing Kubernetes exclusively for 4 of those. We have a tremendous amount of automation today that leverages the cloud-specific Kubernetes offerings. So there's GKE out there on Google, there's EKS on Amazon, there's AKS on Microsoft Azure. And anyone can go in there and click a button and spin up a cluster. I can do that. I haven't written code in 20 years. I probably should not do that. Once you have a cluster, you know, how many clusters do you want? How should the clusters be split up? Do you want a production cluster, a non-production cluster? Do you want a cluster for every application? I mean, there's all kinds of questions that need to be answered, even starting there. What is the networking layer going to look like? How are you going to deploy your applications into it? What things should I run in Kubernetes and what things shouldn't I run in Kubernetes? Fairwinds has spent a lot of years writing software that builds a production-ready environment very, very quickly out of the box. And it's just leveraging best practices with open source Kubernetes. And it spins up that base level infrastructure with all of the opinions around this is how you should do things. And that's everything from, again, how many clusters to how is it monitored. And that's how Fairwinds goes about it. So we have a software piece on the front end, a whole bunch of automation that implements that. And then we have engineers, very bright, talented engineers like Ivan and Luke that you're going to hear from in just a second, that help maintain that infrastructure, answer questions for clients. You know, when people are going to deploy a new thing into their cluster, they come and ask, what do we do to get this service up and running in Kubernetes? Fairwinds, how can you help? And our engineers will sit down, understand what's going on, and help explain how do we go about this next, what needs to be deployed next, et cetera. And then when there's security problems or whatever, we do actually go and tackle those. So that's that first point. Now we're going to dig into best practices for running Kubernetes in production, and I'm going to hand things over to Ivan and Luke.
All right, awesome. Can you hear me okay, Kendall?
Yep, go for it.
Perfect. So first, I'd like to touch a little bit on a somewhat broad topic, but that is of reliability. So reliability is going to mean a lot of different things to a lot of different folks and businesses. You know, depending on what your business priorities are, you're going to have different elements of reliability, but there's a few that we can talk about here that are going to be common and important to most folks. The first one that is big is let's reduce human error. So humans are awesome, but we also make mistakes. And there are certain tenets that we can use to help minimize those mistakes and produce very repeatable results, which are going to help us to scale a lot farther and a lot more quickly. One of the biggest pieces to this to start with is infrastructure as code. So infrastructure as code is essentially representing your infrastructure, including networking, cloud resources, your EC2 or Google Compute or Azure Compute instances, all the things represented as code. And so this is going to allow us to produce reliable results in the infrastructure that we build. We're going to be able to standardize environments. So a very common good practice is if you have test, development, staging, production, QA, other environments, you want to know that you're building those environments the same way across the board. So you can also more easily create new environments. So that's going to help you in the area of being able to test changes to your infrastructure or new architecture that you might want to deploy and not have to unveil that, you know, in an environment that could be a lot more costly to your business, like production. Also, having your infrastructure represented in code helps you to track the changes to that infrastructure. Instead of having someone clicking around in a user interface, making ad hoc changes, while that initially might feel more efficient, especially if infrastructure as code is a new concept for you all, representing your infrastructure in code is going to allow you to make changes and be able to audit those changes and go back and review who made the change, when it was made, and hopefully why that change was made. it also kind of serves as
Can I jump in for just a second there, Ivan, and just
Absolutely.
give a real world example of this? So just yesterday, GKE changed some of the ways that they charge for clusters. And there was a discussion on Hacker News about it. A Googler going back and forth with an engineer at a company saying, this is how we built our infrastructure. It had these assumptions in mind, and now you want us to change everything. And the Googler responding was saying, well, hopefully even your clusters are ephemeral. And this engineer was responding at this company saying, well, in theory, they should be, but we have clicked so many buttons in this dashboard and our infrastructure isn't defined as code. And so we have no idea how to recreate these clusters. And we're absolutely terrified of tearing them down because we know there's a setting somewhere in this UI that someone has clicked over time that has changed everything. So that's a super common thing. If everything is as code and the whole thing fell over and you needed to stand it back up, you run a couple lines of code and it comes back up. But
yeah.
Go ahead, Ivan.
Yeah, absolutely a great example of where you want to be able to make a few changes in your clusters and be able to spin new ones up and know that the things you've changed are now adjusted per what might be required from that Google communication. And the other things that you want to stay the same are staying the same. This also serves as a really, really nice way to help onboard new engineers in your organization. And if engineers can start looking at your infrastructure as code as a form of documentation and exposure to how your infrastructure is built, read those comments to figure out why certain decisions were made as well. That's going to be really nice. And the alternative that I've often seen in other organizations is you have that one person or a handful of people who you have to grab all of their time, and they might be key resources in the organization. So for us, using tools like Terraform to manage cloud infrastructure and to manage kind of dependencies of Kubernetes clusters, also even representing your Kubernetes cluster, like Kendall just mentioned, as code, using things like Helm to represent deployments of resources in the Kubernetes clusters themselves, and CI to kind of wrap around all of those pieces, including the deployment of your application. Next, I'm going to go ahead and move on to a quick subtopic under this, which is auditability. We talked a little bit about audit in terms of infrastructure as code, but one particular Kubernetes good practice that we recommend is remember to enable your audit logs for your Kube API server. So of course, storing these audit logs can be expensive, so you want to tune this a bit, and that's something that of course we at Fairwinds can help you with. But if you have those audit logs available at a level that's reasonable to store, as with anything, it's going to be particularly useful in Kubernetes because you can go in and look at, when did this get redeployed, who made this API call, and so on and so forth. Next, cover a little bit on disaster recovery. This ties heavily into you already having your infrastructure as code in place. That's going to make new infrastructure a lot more straightforward and fast to stand up. We tend to lean towards a redeploy model versus a more traditional backup and restore model. So this also helps in terms of you can spin up a new Kubernetes cluster in whatever DR regions you might want to participate in, and essentially redeploy your applications as needed into those new clusters. This ease frees you up to kind of solve the next problems in the DR space. So you're focusing less on how do we rebuild all this stuff the same way, going back to Kendall's example, and you can move on to the next level of problems with DR, which is how do we fail over, how do we fail back, how do we change how we route traffic, those kinds of things. Next set I'll cover quickly is what in Kubernetes is called stateful sets, or running stateful applications. Like Kendall said, we prefer to have things be as ephemeral as possible, including really your Kubernetes clusters. So the fact that you can spin up a new cluster, redeploy your applications, have changes be made to DNS is very powerful. It's certainly possible to store state in Kubernetes, but we don't really recommend it at Fairwinds. We much prefer putting state into cloud services like Cloud SQL or RDS and similar. State does make sense sometimes in Kubernetes for scenarios like very ephemeral dev instances of applications. you might spin up, state in your Kubernetes cluster for a database that doesn't exist very long, or might be part of some QA testing, that kind of thing. So state's definitely possible. It's not something that we really recommend, but customers certainly can and do run state in their Kubernetes clusters. We recommend starting with stateless apps first, and like I said, keeping that state in cloud services. And if you're going to consider doing state in Kubernetes, just save that for a little bit later in your Kubernetes journey.
Yeah, I think that's like, I want to tack on there too, Ivan. I think that's a key part of it, is saving it for later on. That there's a lot of companies, when they're exploring Kubernetes, they read about stateful sets and they're like, oh my gosh, I don't have to pay Amazon for RDS anymore. I can just run it in my Kubernetes cluster. And bad things usually happen. There's ways to do it and do it well, but until you're really familiar with Kubernetes, don't do that. Especially don't do that until you have upgraded Kubernetes multiple times and you understand what all is involved in that process, because that's really where you're going to run into a lot of your headaches too. But anyhow.
Yeah, running stuff like that will end up probably costing you more in engineering time and stuff than it would if you just had a cloud service, generally. Cool. If there's nothing else there, I'll go ahead and jump into the efficiency here and how Kubernetes can help make your org a little bit more efficient. So CI/CD is probably something that you've at least thought about before now. And with Kubernetes, it becomes a little bit more valuable because, like Kendall was mentioning, Kubernetes is an API that empowers developers to interact with it, given the proper permissions in a dev environment, staging environment. And a CI/CD pipeline just makes that all the much easier for you to get testing out really fast, a simple git commit, and you can have an application running in an ephemeral environment and test out your changes very quickly. So it's really good for that dev and QA stage. And then we also recommend the practice of tagging master branch, and then it's just like that is production ready. And then the CI/CD just kicks off the installation. And part of the draw of Kubernetes from the very get-go is just automating a lot of the things that used to be very tough to do as a traditional systems administrator, which is the background I come from. So I'm used to doing things on instances, at least a few years ago, and deploying could be a big event, and the idea is to kind of make that boring and make it repeatable and not like an increase to your blood pressure when you need to deploy. So
not have to put up the websites down for scheduled maintenance banners on your website, right. Those kinds of things.
Yeah, exactly. So a CI/CD pipeline helps there, and you can iterate on the CI/CD part of it pretty regularly in the staging and QA area as well to make sure that that pipeline is running well. So long story short, a best practice is to have a CI/CD pipeline in place. And if you don't currently, it's definitely worth investing the time and researching and how you can do that, at least alongside of your Kubernetes, the start of your Kubernetes journey. If you can get that up and running before, that's all the better. So shift gears a little bit now. Yeah, sorry.
Well, before you move on, so can you say just a little bit more about that? Like in the old world of I need to SSH into this instance, update my application, and do that across all of these instances, whatever. How does that work in Kubernetes with CI/CD? Say just a minute about that and how an engineer should do that, because people should not be SSHing into individual pods and updating services in Kubernetes, right?
That's right. And also, you could argue that you shouldn't really have to run too many kubectl commands. I don't want to start a war on how to pronounce that, kubectl, kubectl, whatever. But yeah, you would argue, especially in production, you don't really want people running any kubectl commands unless it's your administrators investigating a problem. So yeah, it works in CI/CD. Generally, we use CircleCI here, and you can define certain secrets within the pipeline itself, and that's how you kind of get authentication to the cluster. And then you run a lot of these update steps within the CI/CD, so your deployments and whatnot. And some other tools like Istio or some other service meshes, which we won't touch on too much. That's a little bit more of an advanced topic, but can enable like certain A/B deploys, blue-green deploys rather, for some A/B testing. And we've actually developed some tooling around CI/CD that can help with implementing it. In the first slide, and I believe on the last slide, there's a link mentioned for our GitHub org, and under there you can find a lot of our open source tools. So one is Rocket Scripts, which is essentially a lot of our best practice-y kind of scripts that are exposed to your CI/CD pipeline to sort of give you a one-line command to do a lot of things that will simplify that deployment. So yeah, did you have any other thing about that, Kendall, you wanted to cover?
Nope, you covered it. Cool. Thanks.
Awesome. So I'm going to skip the instance group types for a second and talk real quick about resource requests and limits, because I say real quick, I could probably talk this entire webinar about resource requests and limits. They are very important. So if you're not familiar, you can set on a deployment, which eventually make it to the pod itself. You set requests on CPU and memory, and then limits on CPU and memory. So the requests especially play into auto-scaling. When you request CPU and memory, you're requesting a portion of a CPU core and a certain amount of memory. And that gets reserved on a node when it's scheduled for that particular pod. And when the Cube API or the control plane notices that a node is basically at capacity, then it knows not to schedule things there anymore. So it bases all of that around you setting same values for requests. And limits are similar but different, because they are basically saying if my app reaches these values, kill it and restart it, because it's going to get out of hand and maybe overwhelm a server, a workload running server. So it's really important to know your application and load test and know the usages across those metrics. And that kind of, I'll go back now to instance groups and types. So once you know all that, you kind of get a good understanding. If your app is memory heavy, you want to probably use worker nodes that have a little bit more memory instead of CPU and lean more towards that. Same goes for CPU. If it's fairly balanced, there are balanced instance types out there. So the best practice here is to really invest in that load balancing and understand your application and how it's going to use all these things. We can't give you a best practice on instance group and types because it's very workload dependent. So this all kind of ties also into auto scaling. So there's a couple of ways that Kubernetes helps you scale horizontally. The first being cluster wide. So cluster autoscaler will launch new nodes when that API notices like, hey, all my servers are filled up with requests. Like I don't have any room for any more pods. And then the cluster autoscaler basically says, okay, give me another node, and then it will get scheduled when that node comes in. So that's the cluster autoscaler at a cluster scale, and then auto scaling at the pod level is also possible via what's a horizontal pod autoscaler. So it's basically, you can think of it like a load balancer with an auto scaling group in whatever cloud provider that looks at CPU usage across instances and says, all right, I've reached this threshold of 50% CPU usage or whatever you set as your threshold. I'm going to add another server. But in this case, it's just another pod for your given deployment or workload in the cluster. And so you have a lot of knobs to turn for auto scaling, and it is highly dependent on the workload, of course. But we have some tools. Another open source tool we have is Goldilocks, and it provides a nice, pretty front end for you to see your workloads, what you've set as your requests and limits, and then it watches it over time using a built-in concept to Kubernetes called a vertical pod autoscaler. It receives metrics and says, well, maybe you should adjust your requests and limits to be this value, and you'll be a little bit more efficient in your cluster. So we do recommend having some sort of tool like that so that you can consistently and evolve your requests and limits as your application changes, because you hope your application gets a lot of traffic, and it's going to change the needs for your application as that happens. So
yeah, I'd jump in here real quick, Luke, and say,
sure.
The vertical pod autoscaler's there. Nobody uses it because most people don't know how, and Goldilocks makes it easy. It's an open source project, as Luke mentioned. Anyone can use it if you're running Kubernetes. Check it out. There is cost savings as a potential in that, depending on which way you're wrongly using instance types. There could be cost increases by realizing you're doing it wrong. But there's definitely optimization to be had there in one direction. Carry on, Luke.
Yeah, and that's a great segue for cost into spot instances. A lot of folks are interested in this, especially if they're a little cost averse or at least cost sensitive about their Kubernetes cluster. Spot instances do kind of throw an interesting wrench because they can be pulled out from under your cluster, by the cloud provider when the price goes up or down based on what you said you want. So there are tools out there, and we use mixed instance policies so that you can give a group of spot instance types. So if one of them gets taken out, it can create another server behind it. So it's definitely a best practice to look into these tools and how they will help you deal with spot instances, because they can be tricky. We do recommend there also being just a baseline of on-demand nodes, because there are important workloads at the cluster level that you do not want to really interrupt, or at least have the amount of interruption as possible. And you can assign those types of workloads to those specific on-demand nodes. And another thing to take into account is always fall back on on-demand. So you can set your policies to spin up on-demand nodes in place of the spot instances if they're taken out. And there's another tool, I believe it's the K8, it's like a termination watcher, some sort of, it's a daemon set that runs in your cluster, watches at the node level, because all the cloud providers will send basically a metadata alert of sorts to say you have 2 minutes and then we're taking the server down. And it will drain the node of all the pods. So it would definitely be a best practice to implement that if you're going to go down the spot instance route. Another route you could go instead of spot instances, if you have a pretty steady amount of nodes you'll need in your cluster, is just reserving instances. And at the very least, you can reserve the on-demand instances that will always be present besides the spot instances. So.
Because having the computing resources you need is depressingly a best practice that not everyone's using.
Indeed.
Yeah. Okay, well, for the sake of time, we should pick up a little bit, so we've got plenty of time for question and answer at the end here, but are you ready for monitoring and alerting here? Luke, I haven't.
Yes,
I don't know who's doing this one.
Let's do it. So yeah, a few pieces of monitoring. To the surprise of probably not many folks, there's also monitoring as code. In operations and so on, we've been doing this for a while. You've got your Nagios configs, Nagios, whatever, from the days of yore in some cases, and it's easy to represent monitoring in the form of some sort of code or configuration. The goal here, though, is to have a practice of keeping your monitors consistent across your Kubernetes clusters. And in a bit, I think Luke's going to say a little bit more about a really nice option that we have for that. But the goal here, kind of on a higher level, is to keep your monitors consistent, expose your monitors and your service availability to not only operations folks, but also to developers, so that you can increase their ability to really own the availability of their services from end to end. There's also a lot of power in having your metrics and your logs in the same place to be able to cross-examine those when you're in troubleshooting mode. I'll say real quickly on kind of a criticality / actionability standpoint. You want to monitor the most critical things. So if you're going to be woken up in the middle of the night, this is not Kubernetes specific, but you want it to be actionable. You want it to be something that you actually care about. You don't want to be woken up because you had some redundant services fail, which are going to heal. And that's not something that you need to necessarily care about until you get up in the morning and you're having your coffee or whatever. Build resilience into your infrastructure and into your application and allow it to heal. That's the big message here for this.
Yeah, and to kind of add on to this monitoring as code, another open source product that we have developed over the last year or so is Astro, and it is aligned with Datadog. We use Datadog a lot here. So Astro is a controller that will run in your cluster, and you can basically put annotations on certain types of resources and say, I want to monitor this resource in Datadog, and Astro will create those monitors for you just based on the annotations. So you don't have to go write a lot of, whether it's Terraform or just pointy clicky at the Datadog interface. You don't have to go do a bunch of that. You define it once in a configuration, and then you apply your annotations for those various metrics, and it creates them for you. And I know we're running, we got to run a little quicker, so that's pretty much all I had to say about that.
I can move on to security implications. Go for it.
All right, awesome. So first big thing that everybody loves is updating and patching. So infrastructure as code also helps a lot with this. Essentially, the best practice is develop a practice of upgrading the things. You can use your test environments, because we just talked earlier about infrastructure as code lets you spin those up almost at will. So this is very different from the data center model, where it might be a little more challenging to have those extra servers and spin up a test environment. And is it going to really be the same? And is it a valid test? So infrastructure as code goes a long way to helping you practice doing your upgrades. If you're comfortable doing it, you're more likely to do it if you're familiar. Another important piece of this is keeping your add-ons updated in your Kubernetes cluster. Besides Kubernetes itself, you have add-ons like ingress controllers, cert manager for managing SSL certificates, things for helping to manage your DNS records automatically. All those things receive updates, and it's important to know when to upgrade. So there's RSS feeds and other things you can subscribe to, and getting alerted or watching the communities for this tooling is a huge important part of knowing what's important to jump on from a patching standpoint.
Yeah, and jumping in with some of the SSL automation, the TLS automation, there's a great tool out there by the JetStack folks called Cert Manager, and it will automatically create certificates for you based on, you can base it off of an ingress, off of an Istio gateway if you're going down that road. I can't say enough good things about Cert Manager. It really, it's a painful thing to talk about in the history of systems administration to update certificates, because it could potentially be a very time-consuming and expensive process back then. But Cert Manager kind of takes a lot of that away when you combine it with Let's Encrypt. So to switch gears a bit to RBAC. RBAC is a topic that is definitely, I think, the most asked about, and like there's a lot of unknowns to people jumping into Kubernetes, and it gets complicated because
don't know what RBAC is. It stands for role-based access control.
Thank you, Kendall. Yeah, and we have once again developed a tool to help with this, RBAC Manager, because there are various pieces to RBAC that you have to implement, all resources in your cluster, and you have to implement usually 3 things to get a policy in place. And RBAC Manager pairs that down into one thing, and one type of object you need to create, and then it handles the rest for you. And yeah, you can jump in with network policies now if you'd like.
All right, awesome. So network policies is a thing that It's a nice way to further segment your applications, components of your applications, or your namespaces in Kubernetes, which namespaces are just another way of segmentation inside your cluster. We recommend that you enable this as an option. So when you are setting up your cluster, you want to make sure that it's possible for you to do network policies, but maybe tackle it incrementally. So the things that we've talked about previously, the things that Luke described around application resource requests and limits, those things are going to be particularly important for the stability of your application. Network policies are a nice add-on to have, but don't tackle that day one.
Yeah, workload identity is probably something, if you're just starting your Kubernetes journey, it might not be a familiar term, and it's basically as if you had an instance in the cloud running and you apply some sort of IAM policy to that instance so that it can interact with the cloud via API. This is the same idea, but we're applying it at the pod level. So there are various ways to implement this in the clouds, in the various cloud providers out there. But it is a recommended best practice so that you're not granting too many permissions to an entire group of instances. You can do it at the pod level.
Finally, managing secrets, and then we'll go on to questions.
Yes, I'm going to speed round through this because we want to make sure and get to as many questions as we can from all of you folks. I want to go back really fast to granting access to things in your cluster. In terms of granting permissions in RBAC, there's some possibility in different clouds to grant permissions in Kubernetes using IAM, Identity Access Management, roles versus using RBAC themselves. We recommend granting minimal cluster access as a best practice using IAM, and then granting the more specific access to Kubernetes objects using RBAC. Mixing and matching IAM and RBAC to grant access inside the cluster quickly gets pretty complex, and there's even IAM roles that are named identically to Kubernetes RBAC roles, but the permissions are different. So that's a quick best practice to throw in there. So moving on to secrets real quick, we highly recommend keeping your secrets out of your images. This might seem obvious, but it's important enough that it's worth mentioning just the same. We recommend either using secrets in Kubernetes as the secrets object that Kubernetes provides, or pulling your secrets from some other. There's plenty of third-party software out there that's great at your applications being able to pull secrets directly. We recommend deploying your secrets not manually, so you can actually integrate this into your continuous integration, into your CI pipelines as well. This is really great best practice because often secrets will get deployed manually. They'll live, quote unquote, securely on somebody's laptop, and it feels like having them there is more secure than the feeling of danger integrating it into CI. However, you can use tools like SOPs, which is a Mozilla created tool as an example, to encrypt secrets using key management service, KMS keys, in whichever cloud. And that way you get this encrypted file that's your secret that isn't readable, that you could commit to maybe even a Git repository, for example. So that's it for me for secrets.
Okay, so we're going to move on to questions here. We've had a number of people ask questions. You're welcome to keep them coming. I'll read these off, answer some, pose some to Ivan and Luke. So we were asked any best practices for running databases in Kubernetes and related with running stateful applications in K8s and using managed services, for example, RDS, Cloud SQL. Wouldn't this result in vendor lock-in? So we touched a little bit on running databases in Kubernetes. It is technically doable. It is generally not advised. Yes, in theory, if you run your database in Kubernetes, that results in less vendor lock-in. However, my argument here would be that there's some give and take here. In theory with Kubernetes, you can run everything in Kubernetes and in no way be locked into your vendor. That's in theory. Now, the way you stand up Kubernetes on every vendor is going to be specific. And there's, if running your database on RDS is going to be so much easier than spinning it yourself inside of Kubernetes, that if you decide to migrate later on, it's going to be worth the pain of getting it out of RDS and putting it somewhere else more than it is to deal with the day-to-day pain of running your own database. So there's some complexity there and some give and take there. Ivan, Luke, you have anything to say about that?
Yeah, no, those are good questions and a good answer. But I'll just add that there are usually open source alternatives to those cloud provided services that the API to them is essentially the same. So while you may have some vendor lock-in in how you launch the service versus running it in Kubernetes, once you're there, the application that interacts with it probably won't see any difference. So one other consideration to think about.
Sure. So then there's this question, if you're managing, I'm not going in a particular order here. I'm going to try to knock out as many as possible though. So if you're managing or building a monolith, what would you recommend being the best approach to containerize and gradually run in Kubernetes? And I'll take a stab at this as well, and then feel free to correct me, gentlemen. So first of all, you can run a monolith in Kubernetes. You can just deploy an enormous monolith into Kubernetes. The advantages of having microservices are many, and it depends on your organization and your specific application. The very simple example that I like to give to people is, say you're running an e-commerce site and your core application is your e-commerce website, but you also have a separate application that's your cart. Well, you probably don't need to use as much compute for your cart as you do for your core application, because a lot more people shop than buy. And so if you have those as separate microservices, you can have less instances of your cart running. Whereas if it's one big monolith that's running both the application and the cart, you have to scale all of those things all the time. Kubernetes is really good if you set resource limits and triggers for scaling to scale up one or the other based on need. And so there's some advantages to, we need to ship code. Well, instead of having to update everything, you make one minor change to your cart application. You only update the cart application. You don't have to update the core service. So it's not moving to Kubernetes does not mean tearing apart your monolith inherently. Run your monolith in Kubernetes if you're running your monolith right now. If you want to split things out, there's reasons to split them out, but it's not okay, you have a monolith and you have to have 50 services before you use Kubernetes. Anything to say about that, Luke, Ivan, to correct me on that?
Yeah, as for the part of the question that was, if I'm gonna just move my whole monolith into Kubernetes, how can I kind of start with that? If you aren't in the scenario where you can, there's monolith as a code base that may still have individual components, which is tied into what Kendall just described. And there's also, I have literally one app and it's a monolith and it all has to run one place or the other. Sometimes you can ease your way into Kubernetes by containerizing that application, doing the work around resource requests and limits, doing some testing, and then if you can orchestrate routing some percentage of your traffic into Kubernetes while still routing the majority to the application that you've been running in whatever infrastructure, that can be a nice way to start kind of feathering in without the fear of committing over everything all at once.
Yeah, and I don't know if this is a contentious opinion, but I'm not opposed to monoliths. I think that a lot of times it makes a lot of sense, but as Kendall alluded to, the benefit of microservices, if this is applicable to your application, is scaling separate parts separately. And you just know that if you're breaking things up into microservices, you're gonna need to take into account like HTTP latency if they're interacting over HTTP or gRPC, whatever it is. Take that into account too.
So real quick, one of the questions is, can we put our GitHub repo, the link to that in the slide deck? That is right here. That's the github.com/fairwindsops. That will get you there if you want to dig around and look at those open source projects. For the next question, how opinionated are you when suggesting tools to integrate with Kubernetes? And again, well, should I keep starting these and then punting to y'all, or do you want to go ahead?
I think it depends, right? So I mean, we certainly have formulated opinions, based on the experience that we have, and how opinionated are we? I mean, it's a joke, but it's also really an answer. That it really does depend on what your definition of all that is. So not to push the question off, but I will say that us being opinionated is something that is based on experience. It's also something that we are more than happy to describe and discuss. So I think there's different ways of being opinionated. Some of those have a bit of a negative connotation. We're definitely open as a company and as individuals about, here's why we have chosen XYZ and so on and so forth. While we're working with our customers, while we do offer a platform and we manage things for you, we also teach you to fish. And so that's part of that equation for sure.
And I would say there's certain things that us as a company managing lots of infrastructure at scale requires us to be strongly opinionated about. For example, we're much less opinionated about what CI tool you use. We have customers using Jenkins, GitLab CI, Circle CI, all kinds of things. We point people to Circle by default. It's not a thing that we hold hard and fast. If you want to use Fairwinds, you must use Datadog, because to monitor at the scale that we monitor, we need to centralize on one tool. Is Prometheus a great tool? Yes. Can you implement it and have it do all of the things well? Yes. If you hire us to do it, we're going to strongly have an opinionated on certain things. And some of our opinions are also like, this is just better to use, or versus this has a business case for us. So there's some of that. Yeah. Along those lines, do we need to know Docker to work with Kubernetes? And I have some comments about that, but I'm going to yield to y'all on that.
I would say you should probably know a good bit of Docker if you're going to be administrating the cluster, of course, because there are, as much as we like to abstract things away into Kubernetes, there are times certainly where you might want to figure out what is causing a particular issue, and you might have to dig down into that. If you're a developer, I would say Docker also makes a lot of sense to be familiar with, because that's how you're probably most likely going to package things up, and there are other runtimes for containers, but so Docker maybe isn't the only thing to think about, but it's certainly, I would say yes. long answer, short.
Yeah, there's ways to get around it, but the short answer is just yes. We only have 3 more minutes because we need to leave time at the top of the hour for the drawing for some prizes. But let's get through just a few more here real quick. What advice would you give to someone starting their first cluster, a managed cluster, GKE, EKS, or install from scratch? And my quick answer to this is going to be go in and click a couple buttons on GKE or EKS and get a cluster and start kicking the tires with it. If you want to do more than kick the tires, hire us, we'll make it easy. If you want to know all the ins and outs of it, go watch the Kubernetes the hard way and spin it the really slow, difficult way, and learn all the ins and outs. Anything to say about that, Luke, Ivan?
I think if you want to understand the underpinnings and the depth, you can do it in parallel, right? Click that button, spin up a cluster, get experience with using it, and then also learn in parallel, what's really happening under the hood. But if you focus too much on doing Kubernetes the hard way, which is an awesome exposure for sure, and similar kinds of things, you can get lost in those weeds sometimes, and then you're not doing Kubernetes.
Yeah. So I'll answer one more question, and then we'll hand things back over to the moderators. Cluster Ops observability monitoring piece looks interesting. I'm assuming somebody's looking at our website asking this. What do you do better than others in this segment? So to wrap up with a nice sales pitch, you've heard pieces about our core offering is Cluster Ops. We will build and maintain Kubernetes infrastructure for you at scale, production ready. We will respond to pager. We can get you there quickly, make it painless, etc. All of those things. That is our core offering at Fairwinds. We offer that both with hands-on keyboard. We offer an advisory if you want to do it all yourself and just have us around to ask questions. And then finally, I think what you're asking about here is something we call Fairwinds Insights. So that's a new software platform that we have. Fairwinds Insights rolls together a couple of our open source tools. One's called Polaris, one's called Goldilocks, pulls in a few other things related to security and cost optimization. Basically, this is a tool that is going to help you ensure that you're running Kubernetes, the same things we talked about at the beginning, securely, reliably, and efficiently. There's a lot of companies, big and small, are afraid of adopting Kubernetes because they think it's going to take too long and they're afraid they're not going to do it right. And you can hire us to help make a lot of that pain go away. You can also use our tools to run those yourself, and then you have insight into that. That's what we really do differently. Is the average monitoring tool or observability tool is telling you, is your infrastructure on fire? Is something down? Is it caving in? Our tool says, maybe it's up and running, but there's gasoline everywhere, and there's a candle on, and your house is going to explode soon. So get in there and fix some of these things proactively. It's a tool that helps with those things. And with that, I need to turn it back over to the moderators. Thank you, Luke. Thank you, Ivan.
Thank you,
Charlie.
Yeah,
Thank you all.
guys. Great presentation, guys. Thanks to everybody who did submit questions. If for some reason they didn't get to your question, please know that they're going to get a copy of all of the questions that came in. So I'm sure they'll be more than happy to follow up with you offline. Okay, without further ado, want to do that drawing for the $350 Amazon gift card. So let's go ahead and do that now. Let's see. Our first winner today is Dan M. Congratulations, Dan. Our second winner is Steve B. Congratulations, Steve. And our third winner is Ken R. Congratulations, Ken. Guys, we'll be checking in with you offline after today's webinar. We'll send you an email that to get your $50 Amazon gift card out to you. So congratulations again. Do want to remind the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. We are going to be sending out an email after today's webinar that contains a link to access the webinar on demand. And the webinar is also going to be living on the devops.com website. So you can always go look for it there. Just go to devops.com/webinars, look in the on-demand section, and it should be right there waiting for you. And while you're there, please check out all of our other webinars, both upcoming and on demand. Hopefully there'll be one or two that pique your interest. Kendall, Luke, Ivan, thank you so much for a great presentation. Good stuff, man. Really like it. All right. Great, great, great. Also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody. Enjoy the rest of your week.